Here we are then, 50 not out. Hopefully you've been keeping up and doing the questions. This question is trying to help James, who seems he might have got a bit lost, trying to help him get home again. So, as is often the case, I'm going to start by drawing a little diagram telling me what's happening. So if we take his starting point and the first leg of his journey, 3i plus 4j, that's my way of expressing that in a diagram. And from there, he then moves on a vector of minus 2i plus 5j, looks something like that. And then finally, his third leg is I minus 7j. So that looks something like that. So he's now at the point P. So the question's asking us at this point, how far is Jack away from his starting point? So that's this distance here. Now, it is possible to do that with trigonometry. I wouldn't like to do that with trigonometry. The question anyway suggests that vectors might be the best way to do this. So in order to find the location where Jack is, I'm looking at the position vector OP. And OP is simply the addition of these three vectors. OP is 3i plus 4j minus 2i plus 5j plus I minus 7j, which ends up being 2i plus 2j. And so the question is asking how far he is from his starting point, and that's just the length of that vector there. So the length of that vector is the square root of 2 squared plus 2 squared, Pythagoras, and that's the square root of 8. Now, if you left it like that, you wouldn't get the answer mark, because the actual answer to the question has to be written in the context of the question. Context is that he's about 2.83 kilometers from home. That's the proper answer to the question. Now, the final part asks what vector represents the path he needs to follow to get home. Well, to get home from P, he needs to go along the vector PO. And PO is the negative of OP, so that's minus 2i minus 2j. So nice little question that. Hopefully Jack got home safely, and I hope you got the same answers that I did. And if you did, well done.